do long division with chunking on a number line as my main form of resource. So what I do is I'd introduce the children to the question, which is 60 divided by 8, which I've got written here. You can see that we know that 60 doesn't divide by 8, so we'll be left with a remainder, and that's why I've used this as an example to introduce the children to remainders and how they can be written and how they happen in real life. So to begin with, I would give the children 60 counters, which I've got here. I've split them up already, just to make it easier to see, but the children will be given 60 singular counters and would be asked to then just divide those themselves and see what they end up with. So they would eventually get to the point where they would have 7 lots of 8, which because they'd know to group it into 8s, hopefully, and then there would be left with 4 remaining. This is when I would introduce the children to remainders properly and say to them that in real life things don't always divide perfectly, and that it is okay to have a remainder as long as it is written properly and as long as they use the small r and whatever the remainder is after their answer, because that shows people that there is a remainder available. So once they've got this group, I would then ask the children to explain what the negatives and positives were from using the Numicon. You could also use counters or any other form of sort of singular block counting. So I would say to them, I'd encourage them to say that the positives were probably that it's quite a visual and an active thing, so they can physically count them out in single blocks into groups of 8 from the big group of 60, which would then be good for seeing it in first person. But they would also hopefully say that it took quite a while to get to this point, and it's still quite a small number. If they had a larger number, say a 3-digit or a 4-digit number, they wouldn't be able to count through, or it would take a very long time for them to count through. This is where I'd introduce them to the number line. So on the number line, I would have my top number, which is 60, and I would have 0, and that would be where we would start. So I would say to the children, I'd encourage them to use 2s, 5s and 10s, because I believe they're the easiest multiples to do or to use when doing division or subtraction or really any form of maths. Those are your go-to numbers. So I say to the children, what is 2 times 8? To which they would say 16. And I would then say to them, what is 10 times 8, and does this fit into our total number? So they would say 80, and which I would then say, that's too big, so we can't take that away from 60. I then say, what is 5 times 8? I encourage them to count in their 5s up to the answer, which is 40. So count through, get to 40, and we'd say, okay, so that is the chunk that we're going to take away. So we're going to take away 5 times 8, which is 40, which then leaves us with 20 left over. So that is the first chunk we've taken out. Children should be able to work with the numbers I've chosen. They should be able to work with 5s and 8s, or their 5s at least. If they had a bigger number, they might want to use smaller chunks or bigger chunks. It depends what the numbers are. So going from there, so they then got 20 left. So they then got the next chunk. So I just do the same again. So we've got 1 times 8, which is 8. So we could do that. We could do 2 times 8, which is quite an easy one, which is 16, which the children should feel comfortable doing from 20. I then say to them, can they do 5 times 8? And they know that's 40 already, and they know that that's too big. That would take them past 0, so that would be wrong. So the next one they can do is 2 times 8. So if I go for 2 times 8 down to here, so 2 times 8, that then leaves them with 4 left. That then leaves them with 4 left, which then we know is their remainder, but I then remind the children that they can't fit 8 into there, so that's their remainder of 4. So to find their answer, because this doesn't mean anything to anybody at this point, so to find their answer, they would have, so they've got 1 lot of 8, 2 lots of 8, 3, 4, 5 lots of 8 up here, so 1 times 8, 2 times 8, 3 times 8, 4 times 8, and 5 times 8. And then down here they've got 2 more, so that's 6 times 8 and 7 times 8. So 7 times 8 is the total of these two numbers here, so 40 and 16, which is 56. So that's their 7 times 8, and they are then left with the 4 remainder. So they know that 7 times 8 equals 56, 56, remainder 4. So then from there, they would need to know or have confidence or subject knowledge of the fact that they can turn multiplication into division. So their answer is the equivalent as the two numbers times together. So 7 times 8 is 56, is the same as 56 divided by 8 equals 7. So the children know they've got 7 lots of 8, and their question was 60 divided by 8. So they'd know that 60 divided by 8 equals 7, then with their remainder of 4. So from there, the children would then be able to hopefully move on to a formal written method. So rather than having your number lines with your chunks, they'll be able to cut this side of the graph out and just use your 5 times 8 and your 2 times 8, or even just the answers. So they know that 60 to get to 20 they have 40, and from 20 to 4 is then 16, and they'd be able to add those up and be left with their remainder. From there, they could then do that, possibly move on to jottings and just using it as a mental method, because that is a formally recognised method of mental maths.